Perfect. Right. So, hi everyone, and welcome, and good to see you. And I'm happy to see you guys are already posting things on the chat. Thank you, Peter, for the good intro question. So feel free to introduce yourself in the chat. Where are you tuning from? Are you in the gaming industry or looking into hopping in? Do you have any experience with real-time analytics or Pinot? Just, to spice up a little bit and give us more context about who you are, what are you looking to discover or explore or talk about in this meetup. For those of you who doesn't know me, my name is Yarden Rokach. I am a head of a community at StarTree. And today we have a special guest, and we're all lucky to have Peter Corless. To take us for 1 hour about the topic of open source observability, architecture for gaming industry. Gaming, real-time analytics, insights. I think this is all a very hot topic nowadays. And I'm excited for the upcoming hour. Feel free to write questions in the chat, or even if Peter will allow to open the mic, I think he is.
Sure.
Open the mic and just hop in with your questions. This is an interactive, non-formal meetup. We want you to get the most out of it. And we're happy to learn from every question. So every question is important. And I hope you enjoy. We will also share the meetup recording afterwards on our Slack. And also on our channel. So if you're not following, follow StarTree on LinkedIn and StarTree on X. And feel free to reach out afterwards to Peter or to me directly on Slack. And Peter, the stage is yours. Thank you.
All right. Thank you very much, Yarden. Again, Peter Corless. I'm the Director of Product Marketing here at StarTree. We will be talking about open source observability and architecture for the gaming industry. There are obviously a lot of entrenched players in the observability space, this is not a knock on any of their offerings, but we'll talk about why people are looking to open source to create their own observability stacks and why specifically that might be of interest to the gaming industry. Before we get into this here, I just want to go through my own quick curriculum vitae. I'm not quite an OG gamer, but definitely up there. I've been playing online games since being on my first VAX 11780 at Carnegie Mellon back in the 80s. These days, I play mostly Paradox games. You can see how many hours I've thrown away in my life doing these things. I'm not in the computer gaming industry. I have a background in desktop and tabletop games, so basically like board games, role-playing games, etc. But I have to tip my hat to all the folks who actually do day in, day out, create computer games, because it's completely different art and science. But I am a gamer, and I'd like to ask the audience, if you're a gamer, why don't you put in your favorite game or tell us something a little bit about your own gaming history. So that's just an icebreaker here. I would love to hear how people are. You like a Mac gamer, a PC gamer, a console gamer, a mobile gamer? Love to hear a little bit about your own gaming experience, because again, I want to tailor this towards your interests and needs. Also, if you're in the gaming industry, I would love to hear a little bit about your role there. Are you on the platform engineering side? Are you more on the user interface development side? So tell me a little bit about that, and we can tailor this talk towards your specific interests. So the agenda we're going to go through today is gaming and observability, how this is like a collision of forces that are going on, and how this is resulting in this requirement for an open source disaggregated stack. And what does that mean? Where does real-time analytics play into observability? How does AI play into observability? And what kind of next steps should we be thinking about taking after we've talked about this? So again, this collision of observability and gaming, because games are increasingly complex. These are multiplayer games, and if sync breaks between them, some players left out and they find that suddenly they're a corpse. You need to have, even minor lag issues solved for. People are spending a lot of money on rigs so they can minimize their lag and jitter, and they're expecting their platforms to have that as well. Real-time leaderboards, you want to keep it fresh. And of course, there's a huge diversity in what people are trying to get out of insights on leaderboards these days. So it's not just one leaderboard like we used to have. There's a plethora of them. And then, of course, very sophisticated backends. Even for a simple mobile game, you can see very complex sort of infrastructure driving that on the back-endian side. And also, what happens when all of this infrastructure fails? It can be 24 hours of hell. And so the Sony PlayStation Network, the whole, not just a game, but the whole network fell apart for 24 hours in February. And there's an expression in this kind of site reliability engineering and platform engineering thing called hug ops, where you basically care about the people because they're going through the worst nightmares you can imagine. So hug ops for all for that outage. And that's when the system utterly systemically fails. Now, oftentimes it's not a complete failure. It could be just some problem that's occurring for a subset of the players or for a specific geographic area, or something's going on where the damage is contained. And this can actually be driven by success. So for instance, for Fortnite, when they had the remix, the finale, that was back in November, just a couple of months ago, they had 14 million users and more people wanted to join, but they couldn't. They were being shut out of the system. So you can either have a complete failure or a complete success, and both of those extremes can drive any sort of issues. Let's see. So the next thing is, again, we've talked about this. You need to bring your A game. Your players are bringing their A game. And they want to make sure that their favorite games and their favorite publishers and their favorite game networks are providing them the seamless experience where if they're up to getting these achievements, if they're up to getting these first place prizes, that, it was not the infrastructure that held them back. Nobody wants to feel like we just wiped on a boss because the system lagged. So what's at stake here can be divided into risks at the endpoints, whether at the mobile or desktop or the consoles. It can be somewhere in the network, and it can be somewhere in the back-end infrastructure. And if any of these are not operating performantly, reliably, crashless, then the users are left with the perception that this game sucks. Even if you've done all the beautiful artwork, even if you have this incredible story, if actually playing it results in this kind of issue of connection or jitter or whatever it is, people have this perception like, I can't play this. I have other things to do with my leisure hours. So let's go through the gentle art of not sucking. There's a lot of different kinds of observability that need to be applied here, whether it's application performance monitoring, whether it's network performance monitoring, it could be database monitoring. There could be AI infrastructure you also need to calibrate, anomaly detection or log analytics. There's each of these in and of themselves would be an hour or more webinar by themselves, right? A meetup, because these are deep topics that have taken decades to come to the current state of the art. So I don't want to minimize them. I'm saying it's just so much to be done there that we can't cover it here. What we can cover is the architecture to handle this kind of telemetry at scale. And so that's going to lead us towards the disaggregated observability stack. You have literally tens of millions of monthly active users. We saw over 10 million users at a single live login event, right? So you have massive amounts of telemetry to manage, rates of data that are orders of magnitude of, back when I was playing on VAX 11780s, we had like handfuls of players after 11 p.m. when the load went down. These days, systems are just huge, and you need to be able to manage these kind of fleet class services in real time. So there's a need for this to be a much more robust infrastructure. So what are the elements of that? Well, first, let's talk about the three pillars of observability. back when this was coined back in 2017, observability was broken into metrics. And so those would be things like, you know, what is my lag, right? And you'd have a number on like my lag to the server, right? A trace would be, for instance, within the infrastructure, this person's got to go to the authentication server, then they need to go to get their inventory, then they need to go to the bank, you know, and so like there's all these back-endian services that need to call each other. And so traces would be used to kind of watch that distributed transaction within the back-endian infrastructure. And logging, of course, typical kind of log is this player crashed, and you get a log analytic, a log, you know, a crash event kind of thing. And so, and of course, for the server side, it would be like when the player logged in, when the player logged out, you know, tons of event logging as well on the infrastructure as well. And so those are the original three pillars of what was going on with observability. But since then, people added these things like events. And they said, well, actually, a crash is an event. Okay, so let's create a crash dump as a kind of a different sort of thing. So there's metadata about the crash, and then there's the blob that comes with like the crash itself. Okay, so a core dump, maybe, right? So that was events that were added. And then people said, well, maybe beyond this, there's also profiles. So what does the, you know, what's the user profile look like? Or what does the system profile look like? And so profiles were added, and there was now 5 pillars. Then people said, well, what about exception handling? And so exceptions became a 6th pillar. But what's going to continue to happen is more people who have favored new types of telemetry or existing types of telemetry that they're trying to normalize into this model will find a new pillar. And so there's just an infinitely spawning acronym, as it were. So what's happened then is that it used to be that if you had a metric, you would keep it in a metric system like Prometheus is a database that's used for metrics. If you had logs, you would use LogQL, log query language, and you'd keep that in Grafana Loki, which is a great log processing system. Or maybe you use Elasticsearch, also used a lot for logs. And then if you did traces, there might be yet another database for traces, and that might be Grafana Tempo, right? And so each telemetry type had its own database, its own collection system, its own visualization system. And so there was this spawning of however many different types of telemetry you had a different entire stack dedicated towards that. Now, what people are saying is, well, is there a way to throw a tent over this and call it a circus? Is there some way that we can take and create order out of the chaos of all the telemetry that we're managing? Is there some way that the agents can collect all of the data, that we can store the data commonly, we can query it commonly and visualize it commonly? And so, yes, the answer, for instance, like Prometheus, Grafana Loki, Grafana Tempo, you can use the Grafana dashboard across all of them for observability. So visualization, I think a lot of people have figured there's ways of normalizing that. But how about the stack underneath it? Well, in order to deal with this, in order to make Observability 2.0 happen, Charity Majors is the CTO of Honeycomb. She was the person that coined this term, Observability 2.0. And we don't need to go through every single word that she says here, but I gave the link for folks who want to read the thread on Twitter, now X. And she has some very interesting philosophical things to say about what Observability 2.0 is and what it isn't. And so, for instance, it's not just these separate stovepipe telemetry types. It's now based upon what's known as a wide log event, which is a very rich data source. Think about it like a wide column row, okay? So there's tons of data, even potentially derived things that are taken out of, let's say, a complex log structure, and you take some of those and you make that into a metric table, or a metric column in a table, right? So these are going to be a much more sophisticated, rich sort of log entry. And in fact, that's why they're called log events. It's an interesting kind of concept, and will require some data remodeling from people and to rethink how you handle your data to change all of this into a kind of a single table structure. Also, a lot of people are used to seeing that wonderful glass house thing where, like, all the charts are humming wonderfully, and as long as everything is not above or below a certain threshold, you're fine, right? That was the old consideration of observability, which was really more like monitoring, right? Because don't screw with it, let it run, just hope that it doesn't go above or below. But now what has to happen is that you have to really think about what are the root causes of these issues? What made it go above or below that line? Why is this happening? How could we have prevented this? And that gets to the next part, which is driving quality back into this proactively as well as reactively. How could we have made this a better system overall? And it's really to change what observability is from this kind of software janitorial service, like, old-fashioned sysadmin and cleaning up after devs who didn't know how to, like, do good exception handling. It's trying to become a strategic differentiator that you use your observability to make a better operating company from the get-go. So again, it's not just that there's a spec or a standard that people need to follow. It's how you treat your platform engineering such that you're really thinking about a holistic betterment of your organization and your systems. So getting more into these wide log events, one of the things that happens is that it's going to lead towards very high cardinality and very high dimensionality data. And a lot of traditional systems that have been used to handle this kind of stuff may not be appropriate for Observability 2.0 because they're just going to sputter when they hit high cardinality or dimensionality. And you have to have context-rich data. So potentially you may have had to decorate it or annotate it or merge it or do some sort of pre-processing of it even before it hits your database system. So we can get into that a little bit later, but think about stream processing as the way we can take the raw data we have and we can turn it into a context-rich data system that we have so that all of those derived metrics are already kind of pre-calculated when it hits the system. Now, this scares a lot of folks that have been running successfully. I have Prometheus running, I have Grafana Loki running. I'm happy. Why do I need to change here? That sounds like it's a great leap forward. Now, some people who've been doing this for a while, you can talk to some of the closed source vendors like a Dynatrace or a Honeycomb. They've figured how to do this with their own closed source systems. But for open source systems, you might need to think about how you're going to do data modeling, how you're going to do data ingest, what's the platform you're going to do. And so what we've found here, and this is the experience we're getting at StarTree, is a lot of customers like, don't worry about changing the telemetry types yet. The first thing we want to do is at least round them all up into a common data repository that can scale. And that's where we'll talk more about how our platform works. But basically, you keep your logs, your traces, your metrics are all the same telemetry types, but at least they're in a common repository. So that, for instance, you might be able to do interesting joins across telemetry types, or some sort of way that you can combine both the observability data with your business data on the same common repository. So you haven't changed your data model yet. All you've done is you've given a sanity check, and you've given a platform for scalability. Now let's take a look at how this data is coming in. Traditionally, you would have batch data collection. Just think about mobile games. They're not always, a mobile phone may have been turned off. A mobile phone may have been disconnected from networks, such as an airplane mode, and you play that game the whole airplane ride long. And then when you get off and you finally reconnected, there may be some information that needs to go from your phone back to the mobile game system. So maybe you've cleared out a couple of levels and they need to know about that. You need to get added to some leaderboards. So batch data collection is not going to go away at any time soon. But for the infrastructural level, especially maybe at the network, the cloud, the server level, this is where these are always on core systems that have data that you want to stream in real time. And so you need a different kind of infrastructure to collect that and stream it. And then it may not just go to a single storage backend. Some might go to the data warehouse, others for real-time analytics, right? So there could be potentially multiple consumers of that streaming data telemetry. And so you want to have an infrastructure that supports that. And so this is where we've seen a lot of our users, and not just our customers, but open source users are interested in a kind of a new stack for real-time data aggregation where you use Apache Kafka for all the streaming topics. So this might be topics related to a specific game or maybe to a specific server, right? So the way that topics get created needs to be based upon the organization and the data that you're collecting. The stream processing system, Apache Flink, then is that place within which you might do pre-joins before you send them into a database, so you can have a denormalized data set. It might be a place where you're doing derived statistics and metrics. It might be a place where you're doing that kind of decoration and annotation. I have this other source, and I'm going to take this data stream and I'm going to add some things into it that I have from other sources to enrich this data that I have. And then Apache Pinot is a real-time analytical database. We'll talk more about that, but that's the place where you would then run and power your dashboards and your leaderboards off of things like that. So this is just an example of an open source stack that can be used for observability and specifically for the gaming industry. So now let's take a look at some of the specific considerations of the gaming industry, right? Let's lift that fog of war. Gaming industry companies need to drive their business as well as monitor their business with systems. So, again, they might be doing ads and offers. They might be, upselling things, so there's a transactional side of the business. And then that transactional side then needs to be analyzed. So who did accept that personal offer? Who did buy that special package, right? You have these multidimensional leaderboards. There is, of course, heat map tracking. So like where are the players congregating in the world that you have? Are they all bunching up in the new zone? And do we need to distribute the player base to different locations to like have maybe better server performance, things like that? Adaptive gameplay. All of these things are what's going on in the overall architecture of it. And the problem has been that in the past, your observability system was a bolt-on, was an afterthought. And all of these business considerations had certain data systems that were used to drive them. And then all these observability systems were completely orthogonal to the organization. And people were like, can we get one database to rule them all, to borrow the line from Lord of the Rings? And in order to do observability right, one of the things we found was that just the raw performance speed of a lot of systems, the data warehouse will produce results in minutes, maybe even hours. It's not going to be fresh off of a data warehouse. Even transactional systems that might be great for single read and write of rows don't work as well for speed if you're trying to do aggregations against your entire player base. And so OLTP systems may fail. Search engines were never really designed for high query concurrency. And so they might have been a great place to store some logs. But for instance, if you want to have a dashboard of like, let's say a player wants to see, well, what has my performance been like? You want to kind of provide feedback to the user to show them like, no, it's not just your imagination. Like, here's where your service level has been. That kind of speed you might not get out of a search engine. Fidelity, sophistication. There's a whole lot of things that have been holding back what we've been able to elevate to players because we just don't want to run too many queries per second against them. And this is where, again, our company has this offering. Apache Pinot is at the heart of StarTree Cloud. And there are literally customers out there that are running petabyte scale data and still can run against that and get sub-second query performance against it. And I've had people say, no, you can't do that. But there's a whole, again, another hour that we can go into like how we built StarTree and why it's built on Apache Pinot that can answer the reason why it performs very quickly. And the other thing too is that it's very efficient in terms of storage. And again, another time we can talk about why, but this is the kind of thing is why people are looking at that. They're looking for new ways to manage orders of magnitude more data at orders of magnitude quicker response times. Okay, so Jake has got a question here. Let me just stop right here. I'm a heavy PC gamer. What would you say is the biggest challenge in improving speed in game analytics? So what we were just talking about then, this is the raw scale of the data. There's also the high dimensionality of it. So again, if there was only a few hundred players, it's pretty easy to make a kind of a quick leaderboard out of that. When you've got millions of players, and then for instance, you're trying to slice and dice that data. So like, who's the best leader for this battleground? And how about that battleground? And how about, there's different tiers of play that people have. So, who's the best on this battleground at that tier? Suddenly, this is when you start seeing deeper and deeper analytics and a lot of transactional systems. Again, they're row stores. They were never designed for that kind of aggregation. So you want to have fast aggregations from a database, and you also want to have very sophisticated methods of filtering. Those would be, I think, the two things in particular that you'd be looking for from a data analytics solution. And again, in terms of speed of it, there are some things that we do with Pinot in particular, like very sophisticated indexing techniques. If you guys want to look up, I'll put it in the chat. It's called a star-tree index. Star-tree index. And Yarden, if you can just want to pull up a blog about that, that's a specific methodology for how to kind of do pre-aggregations, not full data cubing, but a very fast kind of performant method of pre-aggregation indexing. And so that's just a secret. I mean, there's tons of arcana in how Pinot gets very fast, but that's just an example of it. Another thing we do is like for upserts. Maybe you have a data record and then quickly right after it, there's like an update to it. The way we do upserts also is very performant, very scalable. So, I mean, check out all of the content we've had from prior meetups. Check out a lot of our blogs on our website, because there are reasons why Pinot is faster than, let's say, and I don't mean to pick on anybody, but an Elasticsearch or a Postgres, or again, any of your data warehouses. It was architecturally built for fast analytics at scale. So, but when you use things like a Pinot, when you use things like a StarTree Cloud powered by Apache Pinot, suddenly again, we're seeing direct feedback from our customers saying that they've been able to drop data ingestion from maybe a day out of date, maybe 48 hours out of date, to literal seconds. Like, going from calendars to stopwatches in terms of data freshness. And then in terms of data queries, they're going from queries that could have taken 2 to 5 minutes. You can't be on a mobile phone waiting for the leaderboard to update for 5 minutes. Like, you're just going to abandon the game. You can't wait. You want to be able to have blink of an eye sort of leaderboard updates. And so that's the kind of performance you have on the query side that we can offer. Again, scale is both measured in terms of raw amount of data. We talk about petabytes stored, but it's also in terms of queries per second, because when you're trying to do analytics for millions of players, 100 million plus player base potentially, that's where Fortnite was, then you have this non-predictive, this stochastic query concurrency. At any moment, there could be some huge run and everybody wants to check out a dashboard or a leaderboard or something like that. And then, there was no traffic, hardly any queries per second one moment, and then suddenly thousands the next. And so that's one of the other issues about StarTree and Apache Pinot. It was invented by LinkedIn when they had 100 million active users. That's when they invented Apache Pinot. And now they have over 1 billion active users, and all of the statistics that you get off of LinkedIn are powered by Pinot. So if they're at 1 billion folks, a gaming company would feel so lucky to have 100 million people using it, or even 10 million. So definitely can keep up with those kind of high queries per second. And then how do you cut costs? Pinot manages it, and then StarTree above manages it by having tiered storage. And with StarTree Cloud, you can actually use Amazon S3 or Azure Blob Storage or Google Cloud Storage to actually take the less frequently or older data and put that in a tiered storage mechanism so that your most recent data can be used to generate fast current dashboards, but you can go back all the way through history with the slower served, cheaper costed object store. And you can combine that in a seamless query. So that's the way we've done tiered storage, and that allows you to save dramatically on cost. So this is kind of what the new stack looks like. So again, you're getting player logs, you're getting all this kind of stuff coming in from that side. It's going through streaming. You get these fast data ingestions, these fast aggregations, high QPS, the tiered storage, and then you can serve whatever you want to, whether it's doing observability for internal utility, whether it's observability dashboards so players can see like what's the fastest server I can play on these days, or like, you know, which servers are yellow light or red light in terms of, you know, how full they are. You can do both internal and external elements of observability for the player base. And then I just want to break this out here. Again, within the streaming spot, you have both the streaming, which would be Kafka, the processing, which would be Flink, and then potentially even governance services, which Confluent offers. That's above and beyond open source, right? That's the paid Confluent services. But for enterprises, they're definitely interested in also moving towards those kind of services as well. Activision is an example where they used it for Call of Duty player stats. Like you can see here, Pinot's working like a dream, right? So there's a lot of companies, many logos again mentioned today, but there are a lot of companies that are actively already on Apache Pinot or a Pinot-like system, and many others are now embracing this kind of new platform for analytics. And again, I can go into this a whole other hour. If people have specific questions, you're free to mic up or put them in the chat if you want to drill down on any of these particular things. And as I said, you can do back-end insights for observability, and you can do player-facing insights. And you can either do pure play observability, just performance monitoring, et cetera, or you can also kind of blend this with things like leaderboards and more business-oriented kinds of things. I think one of the most interesting things I've been hearing about is like taking customer support tickets and finding out how many support tickets are tied towards specific observability incidents. You know, so maybe this server went offline for a couple of minutes, and we can correlate how did that impact customer satisfaction, as an example. Here's a top 10 video game company. They went to an ingestion lag of less than 10 seconds. So from an event happening on your PC to the time it shows up in the back end for them to be able to do analytical queries against it, less than 10 seconds from that event happening. Then against that data, they can get queries in less than 100 milliseconds. That's literally less than a blink of an eye. And we're using the Pinot query language to then drive Grafana dashboards, just like you would from Prometheus or anything else. And again, these are specific things that they're doing in the query pattern. So they're doing aggregations, they're doing group bys, they're doing these filters. And then they have these different levels of granularity. So they kind of time bucket. So like, you know, who's doing this in the last 30 seconds? Who is seeing this in the last 5 minutes? Etc. And so this became their architecture, where they had the client consoles either on the, you know, PCs or whether it was on game consoles. There was a metrics extractor service, so that like how do you get those from those devices and how do you aggregate them to then send into the real-time analytics. And again, we talked about Flink and its role in stream processing and enriching that data. Apache Kafka becomes this medium, becomes this data superhighway running inside your system, potentially sending data at millions of objects per second into a Pinot, which is designed to be able to ingest at that rate. You know, the analogy I use is if you built an LA freeway but only had a 2-car garage, you couldn't ingest the amount of traffic that was getting off the highway. So you need to build giant parking structures to be able to bring in that Apache Kafka data. So did we have a chance to look at alternatives to Pinot? You know, for this video game company, they had been using something else. They had been using a very fast key value store before this, and it was just not built for the real-time analytical side of things. It could do fast row-by-row writes, but it could not do the aggregations necessary to then drive their dashboards on the far side. And what makes us go with Pinot is that our founders invented Pinot at StarTree. ClickHouse is an option for many companies, by the way, when they are at a kind of a limited scale, where we're often a replacement for other things that have fallen over. Like they've gotten to a certain scale, but then you want to keep on growing. And so, for instance, just as an example, is that ClickHouse is a single binary. And so you can't really scale it independently of like brokers and servers. And so you can become cost inefficient as you scale out ClickHouse because you can't do those kind of two tiers. Whereas for StarTree, as an example, the brokers can be scaled out independently of the servers. And the analogy or the example I give here is there's a huge difference between getting 100,000 queries per second against a single terabyte, or maybe 1,000 queries per second against a petabyte. And the ability to scale out the brokers and the server infrastructure independently allows you to tailor your deployment to the kind of use case you have. Is it a large data volume, or is it a large query volume, or both? And again, because you have that two-tier architecture with StarTree, you can actually tailor your deployment much better than you could with a single binary ClickHouse. And that's just an example. They are very sharp people. There's a lot of people that run on ClickHouse for observability specifically, and they're happy. But we're finding some customers that even go beyond what a typical ClickHouse deployment looks like. And no, that's totally fine. And in case if anybody has other questions like that, feel free to zing me. There's that's totally cool. So I do want to touch a little bit upon AI and observability because this is a very interesting topic and a lot of people have questions about it. Is it ready for prime time? I was going back through the history of AI ops is what it's called. And that term was coined back in 2016. So shouldn't we have already been here? I mean, isn't that a decade? Like, shouldn't everybody have AI observability? But I think it's seen sporadic progress over this past decade. Right? How will we solve every problem ever? AI ops, right? It should be this nirvana. Why aren't we at nirvana yet? And I think that it highly depends upon the organization, the tools they use, the strategies they use, and where they try and implement AI. Right now, I would say that a lot of where AI seems to be working is at the metadata or meta issue tasks, right? So again, like I was talking about the call to ticket correlation or maybe issue summarization. So you have a long 1 hour debrief call where the team was all, with their vendors and a whole bunch of folks, you've all been talking together about like, is it on the client side? Is it the network? Is it the platform team, right? And you want to get a call issue summarization. That's a natural fit for large language models. There is also a utility for AI in simple atomic tasks. So you give it a very specific, discrete thing and say, do this specifically. And those are places where it seems to have worked. Maybe exploring strategies to troubleshoot. So you give it a general parameter of like, a scenario of what's going on, and you say, so how should we go through this? And it could potentially give you interesting suggestions about how a methodology, to troubleshoot it might go. But it's really just an extra tool in the SRE toolkit. Where it seems to have fallen down is, for instance, in understanding issues. AI doesn't really understand anything. It's given a pattern and it sees if there's any way it can synthesize an answer based upon the training data set it has. It also falls down in terms of agentic AI. A lot of people believe that you can just trust your organization to AI and it will automatically repair things magically, like some sort of vacuum, a robotic vacuum. But we haven't seen too many success stories at that level of trusting the AI to run your system without any human intervention. Typically what's going on there is people are still trusting more heuristic, script sort of things, where it's like an if then else statement for that kind of agentic sort of system, as opposed to an AI agent right now. Keeping context over time, that's the sad thing, is that right now, AI is kind of like, they start veering off after a couple of interactive queries, and they forget the context that you had provided in prior elements of the interaction. And so they're not really as useful for unraveling very complex issues. And you're certainly not going to be able to just replace your SRE staff when AI will solve it all. But there are some very interesting companies that are doing very cool stuff with AI ops. And a lot of it, sadly, right now is closed source. Not all of it, though. So if you want to, you can check out keephq.dev. They are an open source AI ops play, as well as Kate's GPT, which is specifically for like an LLM for Kubernetes. So those are two examples of AI ops they're there, right? And they have users. These are not just science experiments, but explore them yourself. If you do, I would love to hear from you. Feel free to get linked in with me. My name, Peter Corliss, is right there. And feel free to get linked into me. And if you have an existing experience with these, I would totally love to interview you, potentially for a follow-up webinar another day. But this is really what we're seeing here, is that AI can be used for observability. You can use, that's what AI ops has been traditionally. But now what we're also seeing is that observability best practices can be used to apply to AI. So how do you detect things like hallucinations? How do you detect an internal trace? And there are companies like, I think Honeyhive is an example of this. And there are some attempts to do observability for AI in an open source kind of manner as well. And I think that this is where the state of the art really is, but it's almost like in the R&D stage. I wouldn't say that there's ready off the shelf tools that you can just pull down and you're all good to go. This is more like IKEA furniture. There's some assembly required, and there's definitely a lot of thought and strategy your organization would need to put in to really understand whether this is a distraction or whether this would be an enhancement of your current SRE practices. Wow. That's a lot to take in. So what kind of concrete next steps can each of us take to understand, to further our understanding of this, to get some hands-on, et cetera? Well, the first thing I'd like to invite you to do is, if the Apache Pinot, the StarTree cloud side of things interest you, please join our community Slack. I'll pause here so you can take out your phones and check out the QR code, or you can just type in stree.ai/Slack. This is where practitioners using our StarTree platform are communicating. There's also an Apache Pinot Slack as well. And if you just want to ping Yarden about that, she'd be more than happy with setting you up on the Apache Pinot Slack as well. Also, keep that phone out, because you guys are all here. You can win a t-shirt if you sign up for our newsletter. Okay, that is our mascot, Dash, and you can see that he's very quick and very pointy. But he's definitely one of the rallying cries we have. We finally have a great open source mascot, and we love it. And the last thing I want to invite everybody, and I mentioned this at the top of the hour, but we have registration now open for a full day of Real-Time Analytics Summit. You can go to rtasummit.com. You can scan this QR code. It will be a full day of events where you can hear from practitioners, not just gaming industry, but you can listen to some incredible stories. I was just listening to Life 360 and what they can do. And if you're interested in how to find your backpack from orbit, that's just an example of the talks that we're going to have. Great use cases from a lot of your favorite brands. Netflix will be talking. CrowdStrike, if you're into cybersecurity, they'll be speaking and presenting. Just an all-star cast of use cases actual production use cases, as well as you can hear from our engineers on how did you build this thing to be able to handle that kind of load. So it's great, a deep dive for both engineers, developers, applications, platform teams, architects, etc. And the awesomest, craziest thing is that it is absolutely free. And here's the other thing too, if you're busy that day, sign up anyway, and you can watch all the content on demand for free. Well, with that, Yarden, I want to, and to all of the audience, I want to thank you guys for your attendance. If you have any questions before we wrap up, feel free to either type it in the chat or just feel free to mic up. But otherwise, I am so glad that you gave me your time and attention today and let me just rant on about some awesome stuff.
Thank you, Peter. Thank you so much. Thank you, everyone. Is anyone having a question? Every question is good. Any question?
Mario, did you have something to say?
I just wanted to say, Peter and Jardine, both of you, thank you for the explainer. It's pretty interesting. I'll follow up. I do a lot of slower processing of data over here. So
exactly. So more of like the batch-oriented stuff back here?
Yeah. We process models, we create models, but we don't have the urgency to do anything real time. But this is as fascinating as can be. So.
Well, again, my hat's off to our customers, the open source community. They are the people that are actually driving the innovation. We can't take credit for the amazing stuff that they're doing with this. And the slides will be made available. Yarden will share that with all attendees, as well as the recording. If you need to watch this a couple of times, I'm telling you, I had to spend a couple of times just writing this to really understand all the concepts being presented.
Yeah, I will share the slides and the Zoom link over an email through meetup.com, and we will also share the recording on StarTree Slack. So make sure you're there.
One other thing is that all this talk about observability 1.5 and 2.0, et cetera, there is a book that will be published by O'Reilly about this, and I'm the author. So if you stick with Yarden, if you sign up for our newsletter, you will be sent a link to when that free ebook will be published. And so there's no charge. It's not as thick as a full nutshell book. It'll just be about 40 pages or so, but it'll go into more in depth. For a friend who was asking about ClickHouse, ClickHouse is definitely mentioned in the book, and it's all about open source observability. So this will be in book form, and you can read more about that probably by the end of the month or so, by the end of April. Awesome. All right. Well, I think I've stunned our audience into utter silence. So thank you, everybody, for attending, and feel free to reach out to myself or Yarden on LinkedIn or in any of our community platforms. And with that, have a great day.
Thanks all. Bye-bye.
Thank you. Bye.